Hello, boys and girls. It's Mr. Malzberger. I'm here to explain how to solve the problems in homework number 2 of probability. So here we go. Hopefully you got most of these right. Number 1, you have a bag of marbles containing 3 cat-eye marbles, 4 swirl, 4 sparkle, and 2 green marbles. You pick 2 marbles one at a time without replacement. You don't put the first one back in the bag. So if you watch the video, you know that on the second pick, there's one less marble, and then depending on what we pick on the first pick, it might change your numerator on the second fraction. So it's 2 picks, 2 fractions. First, let's see how many marbles we have. We have 3 cat, 4 swirl, 4 sparkle. That's 11. And 2 greens makes 13. So there's 13 total marbles. That's going to be my starting denominator every time. So my swirl, I'm doing A here. First pick a swirl. There's 4 swirls, right? 4 swirls. So 4 over 13. And then a cat's eye. There are 3 cat eye marbles. Now here's that without replacement. I did not put the swirl back in, so I started with 13 marbles. Now there's only 12 marbles. Now I'm going to multiply these two together to see what the odds of this actually happening are. I get 4 times 3 is 12, and 13 times 12 is going to be 144 plus 12, which is 156. And if you notice, I don't have a good simplification calculator. I've got 4 times 3 on top right here, which is 12, and I have 12 down here. So I know I can divide this by 12, and I'm going to get 1 on top and 13 on the bottom. So it's a 1 in 13 chance of getting a swirl in a cat's eye. So for B, pick 2 greens in a row. There are only 2 greens. So there's 2 greens on the first pick out of the 13 marbles. The second pick, there's only 12 marbles left in the bag, so I took 1 green out. But I took 1 green out, so there's only 1 green left. So I get 2 on top and 156 on the bottom. And I know that right here I could divide by 2. That's going to simplify down to 1 over half of this. Half of 150 is 75. Half of 6 is 3. So 170, sorry. 78. 1 in 78 chance. All right, going down to C, you don't pick a swirl or a sparkle. So no swirls, no sparkles means cat's eyes and green marbles, and there's 5 of those. So 5 non-swirl or sparkle out of the 13 on the first pick. On my second pick, there will only be 12 marbles left. And since I picked one of these non-swirl or sparkle marbles, there's only 4 left here. So that's 20 over 156. Coming back right here, I see 4 over 12. That's a third, right? Divide both by 4. So I get 1 over 3, so I'm going to get 5 on the top. And 3 times 13 is 39. Okay. D, you pick 2 sparkles in a row. Well, there was 4 sparkles, so 4 sparkles to start out of the 13. Then there's only 12 marbles left in the bag, and since I picked a sparkle, there's now 3. So I'm going to get 12 over 156 again. I saw that right here, so I know that's 1 over 13. All right, moving down to number 2, you have a standard deck of 52 playing cards, 2 colors, red and black, 4 suits, spades, hearts, clubs, diamonds, 13 of each suit. Numbers 2 through 10, jack, queen, king, and ace. The deck has 4 of each type of card. You pick 2 cards one at a time without replacement. You don't put the first one back in the deck. What's the probability in fractions of each of these? Okay, so 52 is going to be my denominator because I got 52 cards for the first pick, but the second pick is going to go down to 51 because I'm never putting anything back. So I'm looking at hearts. Well, there's 13 of each suit right here. So it's 13 hearts to start with out of the 52. And then my second pick, it goes down to 51. And there's 1 less heart, so that's 12. Shoot. I don't seem to see it. I thought I had my calculator right next to me. There it is. All right, here we go. 52 times 51 is going to get us 2,652. And then 12 times 13, I learned that up here is 156. But right here, I see I can simplify 13 over 52, that's a fourth, because there's 4 suits, 13 each. So I can turn that one into a fourth. And then the 4 and the 12 would cancel down to canceling out the 4, leaving just 3. And then 3 over 51, I can divide 51 by 3. It simplifies down to 1 over 17. If you got this, though, you're doing great. All right, you pick a red card and then a club. Well, half the deck is red. There's half red, half black. So half of 52 is 26. That's 13 plus 13. And then I'm going to pick a club. Well, there's one less card, but there's all the clubs, right? Because they're black. Okay. So I already know that 52 times 51 is 2652. 13 times 26, let's see, 13 times 26 is 338. God, I miss those school calculators. Let's see, well, I can turn this into a half right here, right? 26 and 52, so does 13 go into 51? No, 17 does. So it'd be 13 over 2 times 51 is 102, right? Once again, if you got this number, you're doing awesome. I'm going to pick 2 queens in a row. All right, so there are 4 of each type of card. So there's 4 queens in the deck out of the 52 on the first pick. On the second pick, I only have 51 cards left because I didn't put the first one back. And I only have 3 queens left. So that's going to be 12 over 2652, 2,652. I'm going to do some quick simplifications over here. 4 and 52. 4 times 13 is 52. So that's 1 over 13. I simplify that fraction. And then 3 and 51 is 1 over 17. So this simplifies down to 1 over whatever the heck 13 times 17 is. Let's see. 221. That makes sense for some reason, doesn't it? 3 and the 7 give you the 21. That's crazy. All right, moving right along. You pick an ace of spades, then another. Wow. Then another. It's supposed to say another ace. I didn't catch that. That didn't get typed in. Weird. Sorry about that. So obviously you probably left a big question mark on this one. So I wanted you to pick an ace of spades, which is one single card out of the entire deck. Second pick, there's only going to be 51 left. How many aces are left? Well, there's 3. So that would have given you 3 over 2,652. That simplifies down to 1 over 17. So that's going to be 1 over whatever 52 times 17 is, which is 884. Once again, if you got the first number, you're doing fantastic. All right, moving on. We're going to Jub. Jub is getting his closet arranged for life in quarantine. He has 5 bottoms, 2 pairs of sweatpants, and 3 pairs of shorts. He has 9 t-shirts. He has 3 feet coverings, a pair of slippers, some flip-flops, and a pair of Vans. How many possible outfit combinations can he make, assuming he's always wearing all 3? Well, we're going to use the fundamental counting principle. And say we've got 5 bottoms, right? And then he has 9 shirts. So right there's 45 combinations, but then he has 3 different shoes. And I guess you could make a 4th saying no shoes, but he's going to wear shoes at all times. Let's see, that's 45, I said, times 3. 45 times 3 is 120. We do 3 times 40 plus 15, so 135. Possible outfits. He'll be very comfortable. And now finally the last problem, a bike lock has 4 tumblers, each with 0 through 9 on it. How many possible combinations? Well, 0 through 9 is all 10 digits, And there's 4 of them, so it's going to be 10 times 10 times 10 times 10, because that's how many numbers you can make. There's 1,000, so it's going to be 10,000, right? 100 times 1,000 then, 10,000 possible combinations. All right, there you go. Hopefully that cleared up any mistakes you made, and I'll talk to you next time. Take care.